Today we're going to talk about negative exponent rationals. So let's take a look here. We have a to the negative fourth b to the second divided by a b to the third. So this is things that we saw in the past, all right? And we know that this a to the negative fourth or negative exponent rule tells us that we would move this a to the negative fourth to the denominator. So we would have b squared over a to the fourth a b to the third, and then we could clean that up, okay, using our other exponent rules. But what we really didn't talk about is the fact that this a to the negative fourth really means that we have 1 over a to the fourth times b squared over a times b to the third. And so when you're taking a fraction and dividing it by a fraction, we would put that a over 1, and then we would flip it to multiply by this, and that's where the a to the fourth and the a would come together to be a to the fifth in the denominator of the fraction, okay? So we're going to use this idea, the true definition of a negative exponent, in order to answer these negative exponent rationals. Again, keeping in mind, negative exponent rationals are just complex rationals. All right, we have a to the negative second minus b to the negative second divided by a to the negative first plus b to the negative first. So here, this negative exponent cannot move to the other side of this fraction bar. This negative exponent is part of a binomial, okay? So this thing, a to the negative second, is going to become 1 over a to the positive second in its own fraction, minus b to the negative second becomes 1 over b to the positive second in its own fraction. Then we have our division bar. A to the negative first is 1 over a, and b to the negative first is 1 over b. And now that we have this, it looks exactly like all of those complex rationals that we've been dealing with for the past few days, okay? So we have our numerator, where we need to get a common denominator, so I'm going to make this be plus a negative. So the common denominator between those two things would be a squared, b squared. And to go from a squared to a squared, b squared, we would multiply this by b squared and get b squared. And to go from b squared to a squared, b squared, we would multiply this by a squared. So that's going to be minus a squared. So there's nothing else to do with this at the current moment. All right, we're moving on to the denominator. So here, between these two fractions, our common denominator would be a, b. To go from a to ab, we're going to multiply the first fraction by b. To get from b to ab, we're going to multiply the second fraction by a. And we get b plus a over ab. Now, we're dealing with this division bar. So the first one's going to stay the same. However, when we divide rationals, we factor everything as much as possible. Since it is b squared minus a squared, we do need to put b first. So it can be b minus a and b plus a, or b plus a and b minus a. Doesn't matter. Over a squared, b squared. Second fraction, we're going to flip. So that would be ab over b plus a. There's nothing to factor with that at all, but we do have to flip it. Now we're going to start crossing things off. So I noticed the binomial b plus a and b plus a. That gives us 1. A in the numerator can cross off with 1a in the denominator, and b in the numerator can cross off with 1b in the denominator, since those are monomials. That means that we are left with b minus a over ab. So keep in mind, these things, this b minus a, that's a binomial. You cannot cross off this b with the b in the denominator. Same thing with the a's. This is your answer. Okay. So let's look at one more here. So we have 1 plus 5x to the negative first plus 6x to the negative second divided by x to the negative first minus 4x to the negative second. All right, the only difference between the problem that we just talked about and this one is that here we have some coefficients that are other than 1, okay? So we first have to get rid of those negative exponents. Remember, that does not mean that we can move them to the other side of the fraction bar. So here we have 1 plus, now 5x to the negative first, which of those things has the negative exponent? It's the x, so the 5 has to stay in the numerator, and the x is what's going to move to the denominator of that fraction. Plus 6x to the negative second, so the 6 does not have a negative exponent, so it has to remain in the numerator, and the x to the negative second moves to the bottom to get x squared. In the denominator, x to the negative first means we're going to have 1 over x minus 4x to the negative second. So the 4, it's a negative 4, but that does not mean it has a negative exponent. You cannot move that. Okay, but the x squared can move to the denominator. Now we are going to work on figuring out our numerator and denominator before we deal with division. So here, remember that this is just 1 over 1. So our common denominator between all three of those pieces is going to be x squared. To go from 1 to x squared, we're going to multiply by x squared. To go from x to x squared, we're going to multiply by x. And to go from x squared to x squared, we just keep the 6 the same there. Okay? Moving on to the denominator, 1 over x, I'm going to make this be plus a negative 4 over x squared. So the common denominator there is x squared. To go from x to x squared, we're going to multiply the first fraction by x. Second, x and then minus 4. And so then with this, we are going to divide. So this first fraction is going to stay the same, but we're going to factor it. Second fraction is going to flip. Okay, this x minus 4 is a binomial, so we have to keep it together there. Now we're going to cross things off. So x squared is going to cross off with x squared, and nothing else simplifies. So we're left with x plus 2, x plus 3 over x minus 4. So technically, since this didn't cancel with anything, you can leave it as x squared plus 5x plus 6, but just be careful because sometimes it will simplify and cross off with something in the denominator. And that's it.